restart. Question number 5, Kubernetes resource request and limits. How scheduling works and what happens on limit for each. Expected answer, provide the answer request versus limits. What is the request? What is the limits? Minimum and maximum. What happens when limits are exceeded? CPU limits throttled by CFS quota, container stores. Memory limit, out of memory killer kills the container or restarts with the error OM. Quality of services, QoS classes. Guaranteed, burstable, and best. If guaranteed request equals to limits, last to be evicted. Burstable request is lesser than limits, evicted after the best efforts. No request, no limits, first to be evicted. In production, always set requests set limits with care, CPU throttle, memory, OA. What is the hiring manager's expectation? Candidate knows the scheduler uses the request, not the limits. Clear difference between CPU limit, throttle, and memory limit, out of memory kill. Understand QoS classes and eviction orders. Production mindset, set request always, limits with care. Has seen OM killed in real incidents and knows why. What are the common mistakes? If container exceeds its CPU limits, it gets killed. CPU limit wrong. CPU limit throttles the container, it does not kill the container. CPU limit exceed throttled floor, container still. Correct is only memory limit violation causes the OM kill. Memory limit exceeded, OM killed, or restart. Key takeaways, request is equal to scheduling guarantee, CPU limits, throttle, not kill, and memory limit, OM kill, pod, restart. Let's understand this by real life scenario e-commerce system. Customer browses and place order, website, app, front end services, microservice, then database, and then payment shipping, external providers. So how it is running on Kubernetes, front end pod, uh, CPU and memory, then product service, order service, payment service, and database. Every service has its request and limit for the resource. Why Kubernetes? Autoscale with the traffic increase, self-healing, restart filling pods, rolling updates with no downtime time, and efficient resource. Real life scenarios, we have seen the big billion sales. Once sales is started, traffic increases 10x suddenly. Kubernetes HPA detects the high CPU and adds more pods. More pods are running, handles increase traffic smoothly, customer happy, website stays fast, and orders. Key takeaways, Kubernetes helps e-commerce systems stay fast, reliable, and available even during high traffic like big sales. This is the tech stack that we use. Follow up questions for question number 5 and